Okay, so we continue our class on week one. Now we move to the second phase, which is fundamental quantities and units. So let me zoom this in. So measurements play an important role in physics. A unit has to be defined before any kind of measurement can be made. So measurement plays an important role because if you want to carry out experiments, yes, of course, if you did this step by steps involved in scientific method, if you did this, you will be able to understand that for us to carry out an experiment to validate or to verify a law, you will need measurement because if, for instance, if somebody says when a human being who is hungry eats 2 plates of food, he will be satisfied regardless of the hunger. Then, if you eat 10 plates of food, you cannot verify that law, right? You need to eat 2 plates of food to be able to verify. So, if you are hungry, you need to eat 2 plates of food. Then you verify if your hunger is gone. So, but to eat 2 plates of food, you need to be able to measure 2 plates of food. So, it's a similar thing we are saying in physics. Measurement play an important role in physics. And to measure, you see, I said 2 plates, that's a unit. Plate is a unit. So we have 2 of those plates or 2 of those units. So a unit has to be defined before any kind of measurement can be made. And different systems of units have been used in the past. These include the foot pound second, that's FPS system, the centimeter gram second, that's CGS system, and the meter kilogram second, that's MKS system. So the new system, which has now gained universal acceptance, is the System International D units, and that's usually called the SI unit. And we are going to basically discuss this unit of measurement. Now, physical quantities are often divided into fundamental quantities and derived quantities. So pay attention to this. We are going to be discussing quite much about it. Now, fundamental quantities are the basic quantities that are independent of others and cannot be defined in terms of other quantities. So what we mean by this is fundamental quantities are the quantities that exist in their purest form. They are not a combination of one or more quantities. So they are the basic quantities upon which most, though not all, quantities depend. Now, quantities like time, time is not a combination of anything. But when you say volume, volume is a combination of length in 3 dimensions, right? So you have length in the length in the x direction, length in the y direction, length in the z direction, and you combine the three and you form volume. But length itself is a single quantity that is not a combination of one of 2 or more quantities. So we call them fundamental quantities. Now, fundamental units are the basic units upon which other units depend. So fundamental units are the units for fundamental quantities, because fundamental quantities are the quantities upon which other quantities depend, right? Then fundamental units are also the units upon which other units depend. Do you understand that? So they are the units of the fundamental quantities. Okay, I just highlighted that. Now, the 3 most important basic quantities in physics are length, mass, and time. I mentioned this. So now, let me go down. Length may be defined as the extent of space or distance extended. That's, in other terms, it is the distance between 2 points. Length, the distance between 2 points. So if you mark a point here, if you mark a point here, and you mark a point here, and then you check this distance between these 2 points, it's called length. And mass is commonly defined as the quantity of matter or material in the body or in a body. The quantity of matter, or the quantity of material in a body, is termed mass. And time is defined as that in which events are distinguishable with reference to before or after. So, that in which events are distinguishable with reference to before or after. Now, let me bring this here and show us is measuring instruments. So you can see here you have, for time, you have a clock here. You can use stopwatch. For height, which is also length, we have a meter rule here. For, okay, we didn't discuss this. This is also a meter rule for length. And then we have a weighing balance here, which is for weight, which is also for mass, because weight is mass times acceleration due to gravity. We are going to discuss that more later. We're going to discuss that more later. But we also have other fundamental quantities like temperature. Although we didn't mention that, but we're going to mention some of that later. Now, in classical mechanics, so I define time here, right? But I'm going to give another definition here. So in classical mechanics, time is a measurable progression of events from the past through the present to the future. A measurable progression, underline this, a measurable progression of events. A measurable progression of events from the past through the present to the future. Now, you can use any of these definitions and you'll be able to define time. So, now we move to the next page. And on this page, we'll have, now, remember I said I'm going to mention some other fundamental quantities, right? So, here we have table 2.0, fundamental quantities and units. And that's the table 2.0 here. I just had to go back to page 2 so that I will show you the table title. So here we have the quantity. This is the quantity, this is the unit, and this is the unit abbreviation. So we have length. We have length here. Length is measured. The unit is meter, and the unit abbreviation is m. We have time. The unit for time is second. The unit abbreviation is s. We have mass. The unit for mass is kilogram. The unit abbreviation is kg. We have electric current. The unit for that is ampere, and the unit abbreviation is A, capital A. Then we have temperature. Remember I mentioned temperature on page 2. And the unit for temperature is Kelvin, and the unit abbreviation is K. Then we have mole. Mole, we have amount of substance, sorry, the quantity is amount of substance. And the unit is mole, and the abbreviation is mole, M-O-L. Then we have luminous intensity. This is light. The intensity of light. And we have candela. Now remember this, for most times you see this in questions, in past questions, because oftentimes students forget about this one. You know, these are very common, so students easily remember them, but this is not as common as the others. And the unit abbreviation is CD. Now, for derived units, derived quantities and units. So, derived quantities and units are those obtained by some simple combination of the fundamental quantities and units. So, when you combine when you combine two or more fundamental quantities, you obtain derived quantities. That's why it's called derived. That is, they are derived from a particular source. Now, they are dependent on the fundamental quantities and units. Some examples of derived quantities and units are shown below. So we are going to look through some of them here. And this is table 2.1, derived quantities and units. Now, remember I spoke about volume, right? And we have an example on volume here, but let's start with area. So area is length times breadth. But you know, breadth is actually also just length, right? Is length times length, because breadth is length in another direction. So it's still length. So length is measured in meter, because we have here length is measured in meter. The unit abbreviation is m. So m times m will give us m square. Now we have volume. Volume is length times breadth times height. But height is also still length, although in the vertical direction. So we have something like this. If you draw a cube like this, right? If you draw a cube like this, let's say you say this is the length, this is the breadth, and this is the height. But you see that this is also length, except that it is in the vertical direction. While this is also length, this is also length, except that it is in um, the y direction, the x direction. Is it x or y? This is y, this is x, this is z, right? Yeah. So now we have volume. Okay, I've explained that. So when you multiply m by m by m, you get m cubed. We have density, which is mass over volume. Mass over volume. And remember, volume is given by m cubed. So we have mass over, we have kg, sorry, because mass is measured in kg, over meter cube, because volume is meter cube. So if we do um, that basic arithmetic, we're going to have, this will give us kg meter minus 3. This is meter cube, but written on a straight line. This is meter cube. So this minus means 1 over m cube. You understand? So now we have velocity. Velocity is displacement over time, and displacement is distance covered actually, except that it is distance covered in a specific direction. We're going to discuss more about these things later. But displacement is distance in a specified direction. So because it is distance, it is still meter. So we have meter over time. Time is, remember, time is second. If you can see from our chart up here. Now, our advice that you draw, you write out, you draw this table so that you will be looking at it to understand what we are doing here. So you can go back, go back to the section of the video where this table is. You write it out, then you use it to follow what we are doing here. All right, so we're discussing velocity, which is displacement over time. And since displacement is meter over time is second, and these two we can write as meter s minus 1. This dot means multiplication. Then we have acceleration, which is change in velocity over time. So we're actually going to write this formula, derive this formula somewhere, acceleration. But for now, since you have not gotten to that point, I will just explain it a little bit. But now, okay, that would be a little advanced for you. So when we get there, I will do it. So acceleration is change in velocity per time, change in velocity over time. Now this change is, let's say, velocity 1 minus velocity 2 minus velocity 2 over time. Now this is actually change in average velocity, right? Change in average velocity over time. So this will be, since it is average, we are going to divide it by the time. So v1 minus v2, or sorry, v2 minus v1. If we are taking v1 as the initial velocity, v2 as the final velocity, so it will be v2 minus v1 over t gives us the change in average velocity, and then over t again because of this t here. So that will now be this and this